Welcome to Trending Unpacked, the show where viral stories meet everyday curiosity. I want you to cast your mind back to that specific moment recently, that digital jolt, when you were online trying to do something completely routine and the web, or at least a massive chunk of it, just stopped. It wasn't your usual, slow connection or Wi-Fi drop.
Yeah.
This felt different. It felt structural, universal even.
It really did. It was like the modern version of the lights going out, but not in your house,
Yeah.
in this vast invisible city that we all live in now.
Right.
And suddenly that whole digital landscape felt incredibly unstable. You had critical login services failing, which, that means the keys to your entire work life, your personal accounts, they're suddenly just useless.
And e-commerce, I remember that. Try and check out of a cart.
Exactly. E-commerce platforms just couldn't process transactions. So you couldn't buy a thing. And then all the apps on your phone, finance, communication, whatever, they were all just flashing these generic error messages.
Which just confirmed that it wasn't you. It wasn't your device.
No, this was something fundamental, something at the core giving way.
Absolutely. And that's immediate confusion was just immense. You couldn't send a critical email. You couldn't stream the show you were in the middle of. And if you work remotely, maybe you couldn't even log into your company's network. So the question just hanging in the air for that, agonizing hour or so was, what single entity has the power to seize up such a massive percentage of our digital lives?
And what does that sudden shared moment of digital paralysis really teach us about the infrastructure we rely on, every single second of every day without even thinking about it?
Exactly.
That intense collective experience, it points us directly to this massive global infrastructure firm called Cloudflare. And this isn't just about some isolated tech glitch. This event became a kind of a crucial stress test for the whole centralized structure of the modern internet.
So today, we're going to examine exactly what happened. We'll dissect the mechanism of that failure and, most importantly, use this whole incident as a lens to understand the surprising fragility that's hiding just beneath the surface of this high-speed, super optimized digital world we all live in.
Let's get into it.
So we have to start with an infrastructure check. I think for a lot of people, Cloudflare is this invisible utility, maybe a brand logo they see for a second if a website is checking their browser.
Right, the checking your browser before accessing screen.
That's the one. But the sheer scale of their failure proves they are so much more than just a simple service provider. So let's define it. What is Cloudflare, and why does it hold such immense power over the world's web traffic?
It's really necessary to reframe how we think about a company like Cloudflare. They aren't just another tech company. They are a vital foundational layer of global internet infrastructure.
Okay, so not an app, but the plumbing.
The sophisticated high-speed plumbing, exactly. They ensure the rest of the web can operate efficiently and, just as importantly, securely. If you think of the internet as a vast city, Cloudflare handles the critical infrastructure.
Like the highways.
The highways, the digital phone books, and the security systems for almost all of the major districts. They're a huge part of it.
You hear them described as a middleman, sitting between the user you and the websites you're trying to reach. Why would so many sites choose that approach? Why route all their traffic through this one central point?
Well, the motivation is almost purely structural and economic. First off, Cloudflare manages a massive content delivery network, a CDN.
A CDN. Right, that's essential for modern web performance, isn't it?
It's non-negotiable. Instead of a website hosting all its images and videos on one server, maybe thousands of miles away from you, Cloudflare caches or stores copies of that content in data centers all over the world.
So it's closer to you physically.
Exactly. It's closer to where you are, which drastically cuts down latency. That means pages load almost instantly.
Yeah.
That speed advantage is, it's make or break for modern businesses.
Well, the economic incentive is clear.
Yeah.
If you don't use a CDN, your site is slow, and customers will just go somewhere else.
They'll leave in a heartbeat, absolutely. But the integration goes so much deeper than just speed. They are one of the world's biggest providers of DNS routing services.
You mentioned a digital phone book earlier, and that analogy feels right.
It really holds up. When you type in a domain name, say, your bank's website, DNS, is the system that converts that human-readable name into the numerical IP address the server actually understands.
It's like looking up a name to get a phone number.
Precisely. And Cloudflare is tasked with handling that lookup process for millions and millions of critical domains. So if their DNS fails...
the websites become fundamentally unreachable. You can't find them.
Exactly. They just disappear from the map. And then there's the security element, which is equally massive.
This might be the biggest piece of it, right?
It's arguably the most important function that drives this centralization. They offer, state-of-the-art protection against distributed denial of service attacks, or DDoS.
Right, DDoS attacks. That's when attackers just flood a website with so much junk traffic that it crashes.
Yes, they just overwhelm it until it falls over.
Right.
Cloudflare, because of its massive globally distributed network, can absorb and filter enormous amounts of that bad traffic. Any single company trying to do that on its own would just be wiped out.
So companies basically outsource their security to them.
They do, because Cloudflare can achieve a level of protection and scale that is, frankly, unmatched. It's just not economical to build it yourself.
So we have speed, we have the addressing system, and we have security all concentrated within this one giant network. Given that, let's try to quantify the client base. Who exactly is relying on them, which then causes this massive cascading failure?
The breadth is just staggering. It's a huge percentage of the Fortune 500 companies. It's major e-commerce platforms, think global retailers. It's critical government and financial portals. It's a vast array of content and media providers. So when they fail, it's not just some niche corner of the web that goes dark.
It's the core systems of global commerce and governance.
That's it. This centralization of these critical non-optional services, DNS, CDN, and DDoS mitigation, is precisely what transformed a technical glitch into a global economic event.
All right, let's move from the who to the how. We've established this wasn't some external attack. It wasn't a physical disaster. The technical consensus pointed toward a network-level misconfiguration, a routing issue.
Okay.
Now, for our listeners who are a bit more technical, we need to move past the simple analogy and really explain the mechanism. Specifically, what is BGP, and why does one error at Cloudflare instantly become a global problem?
This is the crucial and complex point. So the specific possibilities that were cited revolved around an error in something called the Border Gateway Protocol, or BGP.
BGP.
Think of BGP as the grand master of routing for the entire internet. The global internet is made up of hundreds of thousands of independent networks. They're called autonomous systems, or ACs.
And Cloudflare is one of these ACs.
Cloudflare operates one of the largest and most authoritative ACs in the entire world.
So what kind of authority does an AS have over the internet?
Well, every single AS, like Cloudflare, is responsible for announcing to the rest of the world which IP addresses it can route traffic to. BGP is the protocol that makes sure all these ACs can talk to each other, sharing information about the fastest, most efficient paths for data to travel from point A to point B.
So it's a system built on trust.
The internet, fundamentally, relies on trust. It trusts these authoritative ACs like Cloudflare to broadcast the correct routing paths.
So if Cloudflare, an AS with immense authority, announces bad information, the rest of the world just immediately trusts it and reroutes all their traffic accordingly.
Precisely. That's the heart of the problem. In this scenario, the suspicion was that a network misconfiguration, probably tied to a recent update or a change within Cloudflare's own systems, went wrong.
Like a typo.
It could be as simple as an engineer accidentally inputting an incorrect route announcement, maybe declaring that certain internal IP ranges are suddenly reachable via a different, incorrect path. That one bad instruction is then instantly propagated across the highly interconnected global network of BGP peers.
And because Cloudflare is so central and so many major sites rely on them, that one bad instruction essentially told huge parts of the internet to take a road that just leads to a dead end.
Effectively, yes. And it's actually worse than that, because Cloudflare is such a high authority source. Other routers on the internet tend to prioritize Cloudflare's announcement as the best and most efficient path.
So they jump on the bad information first.
They do. And that creates a global cascading failure. A local, internal human error gets magnified because of the structural authority Cloudflare holds via BGP. The error was immediately distributed to critical infrastructure globally, leading to that instantaneous widespread downtime we all experienced.
So the failure wasn't necessarily a lack of engineering talent.
Not at all. It was the inherent risk of managing systems at that astronomical scale. One tiny mistake can have global consequences.
It's just so frustrating that a single misconfiguration can cause such widespread chaos. What was the immediate response from the company? Were they able to spot the bad instructions quickly?
They were, to their credit, quick to acknowledge the issue was internal and operational. They ruled out an external cyber attack very early on.
Which is good. It stops the panic from spiraling.
It helps, yeah. And that speed of acknowledgement allowed them to focus all their resources on restoration. But, restoring a complex distributed BGP network is not instantaneous. You can't just flip a switch.
Why not?
Because they had to systematically reverse that erroneous configuration and then ensure that the correct routing paths were repropagated across the entire global internet. That's a process that takes time to stabilize and verify. It requires these careful phased rollbacks because if you rush the fix, you can actually introduce new secondary errors.
Right, you could make it even worse.
Exactly. You have to be incredibly methodical.
Okay, let's move beyond the technical side of it for a moment and really quantify the disruption. For our listener, what did this widespread downtime actually look like in practical terms? And how quickly did the world realize the problem was centralized?
The impact was immediate and geographically indifferent. It didn't matter where you were. Within minutes, outage trackers were just lighting up across the globe, showing that major platforms in Europe, Asia, the Americas, they were all experiencing identical critical failures.
It was that universality that was so striking.
It really was.
Let's detail some of those specific practical failures. I remember the chaos around financial transactions being particularly severe.
Oh, the failing of payments was probably the most economically damaging part of it. So many modern e-commerce checkouts rely on Cloudflare for secure connection filtering or, for accelerating the connection to their payment processors.
So when Cloudflare went down,
those connections were just severed instantly. People couldn't complete routine purchases. It just halted consumer spending across major retailers around the world. It wasn't just inconvenient. It was an immediate, albeit temporary, drag on digital commerce.
And beyond shopping, what about services people use for, say, identity verification or for work?
The authentication failures were hugely disruptive. So many companies, especially ones that rely on single sign-on or use Cloudflare's network for secure session management, they saw their login services fail.
So if you couldn't log into your SaaS platform, you just couldn't work.
You're just locked out. We saw critical apps showing these generic server error screens. And it wasn't because the app's own server was down. It was because the network path needed to reach that server, which was routed through Cloudflare, was broken.
And this goes for government services too, right?
Absolutely. Remember, this extends to critical municipal or government portals that rely on this external infrastructure for security and for speed. Their services just became effectively inaccessible to the public.
So the moment the outage hit, it was like instantaneous proof of the dependency we were just talking about. Every single point of failure was just another confirmation of how widely distributed their client base really is.
Indeed. And the timeline of the recovery also illustrated the severity. While Cloudflare's engineers worked incredibly fast, the global restoration process took a substantial amount of time to fully stabilize.
Which proves your point.
It proves that once you introduce bad instructions into a system as complex and interconnected as the internet, reversing that cascade is a painstaking step-by-step process. It can't be rushed, even with the best engineering teams in the world.
This inherent complexity and this massive centralized failure point, it brings us to the core structural critique here. Cloudflare is a marvel of engineering, right? It's designed for speed, for reliability. Yet its failure demonstrated a vulnerability that feels structural, not just technical.
Yeah, that's right.
So what does this centralization tell us about the foundational architecture of the modern internet?
It tells us that the modern internet, while technically still a distributed global network of computers, has evolved operationally into a collection of highly centralized bottlenecks. Key functions, the DNS lookups we talked about, security filtering, the content delivery, they have all clustered around just a handful of massive providers.
Yeah.
Cloudflare, Amazon's AWS, Google Cloud.
And that centralization is driven by the performance gain, but you're suggesting the incentive is deeper than just getting a faster website.
It's overwhelmingly an economic decision. Why would hundreds of thousands of companies each invest millions of dollars building their own DDoS mitigation systems and their own global CDNs?
When they can just outsource it to a specialist like Cloudflare for a fraction of the cost.
For a fraction of the cost, and they receive superior service and greater efficiency. Centralization is an efficiency engine. But that decision creates a massive, singular target.
It really sounds like we have traded architectural resilience for economic and performance optimization.
That is the trade-off.
Yep.
That is the core trade-off of the modern internet. Because such a massive portion of global web traffic uses Cloudflare's DNS and security infrastructure, their network is the single point of failure for an astonishing percentage of the web.
So the system works perfectly until it doesn't.
It works flawlessly 99.999% of the time, delivering lightning-fast, highly secure access. But when that tiny fraction of a percent of failure occurs, the scale of the resulting chaos is global and catastrophic, precisely because of the efficiency that drew everyone to the service in the first place.
When the world's digital highway grinds to a halt like that, the human reaction is just fascinating. People instinctively flee to the platforms that are still working.
Which is usually ex-Twitter.
Usually ex-Twitter, yeah, to confirm they aren't going crazy. What was the immediate cultural conversation like during that outage?
It was a rapid firestorm of recognition. Users across the globe were all reporting identical failures. I can't log in, my payment failed, this app is dead.
Right, everyone is seeing the same thing at the same time.
And it was that synchronous failure that quickly shifted the whole discussion from, ugh, my Wi-Fi is bad, to, oh my God, the internet is broken. It demonstrated this shared, immediate sense of collective vulnerability.
And that collective sense often splits into two things, right? Humor and outright fear.
Absolutely. The humor is almost a necessary release valve. We saw all those trending social media memes comparing the outage to, digital apocalypse scenarios.
Well, I guess I have to read a book now. Jokes.
Exactly. Or go outside. Those jokes are a reflection of that shared cultural recognition, that feeling of helplessness when the tool you rely on for everything from work to talking to your family just vanishes.
But beneath those shared jokes, there's a really serious undercurrent of anxiety, and it drives people immediately toward the worst-case scenarios.
That's the pivot to the theories. When systems fail at this kind of global scale, and the underlying cause is some invisible technical function like BGP routing, the public doesn't generally conclude, subtle network misconfiguration.
No, they look for a villain. They look for external, intentional causes.
When a network failure of this magnitude occurs, especially one that hits critical services, people don't immediately jump to a faulty BGP configuration. They jump to something intentional, something malevolent.
So what were the specific, fear-driven theories that started circulating within that first hour?
They focused overwhelmingly on intentional malicious acts. The first theories immediately suggested that the scale pointed toward a nation-state level cyber attack.
Like a coordinated attack by geopolitical rivals trying to disrupt commerce or infrastructure.
Exactly. Others speculated about intentional government involvement, suggesting a coordinated takedown for surveillance or testing or some other undisclosed control measure.
The sheer scale and the simultaneous nature of the failure just makes conspiracy seem more plausible than simple incompetence.
It does. And yet...
But hold on. Cloudflare is built and managed by some of the most sophisticated network engineers in the world. It feels almost dismissive to just keep calling these repeated events simple human error.
That's a fair point.
I mean, isn't it naive to keep calling them simple errors when they have these global catastrophic implications? Doesn't the sheer scale imply a kind of gross negligence, not just a simple mistake?
That is a crucial challenge to the official narrative of just misconfiguration. And you're right. While the immediate trigger might be a single human error, a typo in a BGP instruction, for example, the catastrophic outcome implies a profound flaw in the systemic defenses.
Okay, so it's not the mistake that's the problem.
It's the fact that the system is designed to instantly broadcast that mistake globally without any robust, instantaneous safeguard. That's the real flaw.
So professionals were focusing on those systemic flaws while the public jumped straight to geopolitical conflict.
That is the key distinction. While the public was theorizing about cyber warfare and coordinated attacks, IT professionals were online actively sharing technical insights, trying to explain the precarious balance of managing these highly complex distributed systems.
They saw it differently.
They understood that BGP propagation failures, while rare, are an inherent risk when you're managing global traffic flow at that speed and scale. They were pointing to operational fragility, not external malice. The contrast between those two narratives, internal fragility versus external attack, is incredibly telling about our relationship with this hidden infrastructure.
Let's synthesize this mass reaction. The memes, the panic, the quick rush to blame. What did this teach us about modern life? It feels like we are just so much more dependent on these invisible platforms than we consciously realize.
We are entirely reliant on them for basic economic and social participation. The widespread discussion that followed the outage was this necessary cultural moment of reflection on our digital dependency.
We talk about the digital economy, but this was a literal demonstration of what happens when that digital foundation just vanishes.
It is. Commerce halts, communication ceases, and access to essential services is just denied.
So the outage didn't just inconvenience us, it literally removed our ability to participate in modern life in a meaningful way.
That's the critical takeaway. It reinforces the fact that digital access is no longer a luxury. It is the primary gateway to essential activities. When authentication services fail, it's not just annoying. It isolates people from their work, their finances, their communities.
And the research confirms this isn't some isolated incident, right? This isn't unique to Cloudflare.
Not at all. Outages of major infrastructure providers have occurred before, and they will occur again. It reinforces that this is a systemic stress point. And every time it happens, it chips away at our collective confidence in the stability of this ultra-optimized digital infrastructure. The cultural dependence is absolute, and the fragility is, frankly, unsettlingly high. So if we step back and look at the larger pattern here, What does an incident like this fundamentally reveal about the current state of global digital infrastructure?
I think the most important lesson is a really hard truth. Despite this appearance of a boundless, robust connection, the system is brittle. It feels fundamentally fragile, even at the highest levels of performance engineering.
That is the essential realization. Modern life has moved nearly every core function, from healthcare records and financial clearinghouses to communication and supply chain logistics, onto cloud services, DNS providers, and global networks.
And that move away from local proprietary infrastructure towards these centralized outsourced cloud solutions over the last decade
Has created immense performance gains, but it has simultaneously aggregated all the risk into a few single points.
If this same outage had happened, say, 15 years ago, before this massive shift to cloud computing, the impact would have been far less severe, wouldn't it?
Oh, significantly less. 15 years ago, a DNS routing error from one provider would have affected a fraction of the current global web. Far fewer transactions would have been tied to centralized authentication systems.
But today, because we've centralized this digital metropolis,
But one structural pillar like Cloudflare gets compromised, the tremors are felt everywhere, instantaneously. The very efficiency of centralization is what makes the eventual failure not only guaranteed, but exponentially more impactful. This outage is a vivid illustration of the fragility that's inherent in a highly efficient, highly interdependent global system.
Cloudflare's whole mission is to provide better security and performance. It promises this idea of centralized resilience. One single, massive entity protecting millions of customers. Yet, that centralized strength is exactly what led to the universal catastrophic failure. Let's unpack that paradox.
This is the core dilemma of modern digital architecture. Centralization, as we've been discussing, is incredibly strong when it comes to optimizing performance and security. That's the strength part of it.
Right.
Cloudflare offers advanced DDoS mitigation, superior caching, and sophisticated security filtering that no medium-sized company could ever afford to build on their own. They effectively raise the resilience floor for everyone.
But the very act of everyone trusting that single high floor is what creates the most critical single point of failure possible.
Precisely. That concentration of trust and function dramatically increases the systemic risk. If one company controls the primary security checkpoint for, say, 25% of the web, then any internal error in that company's operational process immediately translates into a 25% global outage.
We optimize for speed and immediate security by consolidating, but we accept a huge compromise on architectural independence and redundancy.
It is the technological equivalent of putting all of your eggs in one, meticulously engineered but single basket.
And crucially, this is all driven by economics. The cost saving of outsourcing this complexity to Cloudflare far outweighs the perceived risk of an outage until the outage actually happens.
That is the critical economic driver. Businesses have to weigh the certainty of high operational costs like building redundancy across multiple competing providers against the low probability of a catastrophic centralized failure.
And most businesses rationally choose the cost savings.
Of course. They choose the convenience of a single, highly effective provider. They get locked in by the efficiency, and this collective lock-in is what creates the systemic risk for the entire global internet. The paradox is that the most efficient way to build a digital system is also, inherently, the most fragile way to manage its operation. So if the structural risk is inherent and the economic drivers all favor centralization, what are the actionable steps? What are infrastructure experts recommending to mitigate these recurring catastrophic failures?
Right, because we can't just stop using these massive providers, so the focus has to be on mitigating the structural risk itself. What does that actually look like in practice?
The primary focus is on implementing mandatory architectural redundancy and moving far beyond just traditional failovers. Experts are pushing for robust multi-cloud and multi-CDN architectures.
So redundancy doesn't just mean having a backup.
It means ensuring that your backup infrastructure utilizes fundamentally different routing and DNS providers.
Okay, so if Cloudflare fails because of a BGP issue, your backup system must be with a different autonomous system, an AS, that is not vulnerable to that same type of routing error.
Exactly. This requires organizations to strategically distribute their core functionality. For instance, implementing distributed DNS failover strategies, making sure that their domain names can be resolved across 2 or 3 different major DNS providers at the same time.
So if one centralized provider goes offline, the global phone book, the DNS, still works for your business through a competing provider.
That is the costly, complex, but necessary shift away from total dependency.
And what about the decentralization aspect? I mean, how can we feasibly decentralize when the economic pull of centralization is so powerful?
Well, decentralization, in this context, it doesn't mean going back to individual servers in a closet. It means strategic dispersal. It involves deploying critical functions, especially authentication and DNS, onto a diverse array of platforms rather than one monolithic structure. It's about creating systems of peer-to-peer trust in some non-commercial applications, and strategically using smaller, more geographically diverse infrastructure providers for backup.
So the goal is just ensuring that no single provider holds the critical choke point for any essential function.
That's the idea.
And finally, let's talk about the human error that so often triggers these events. How do they recommend managing system configuration at this scale to prevent an internal typo from becoming a global BGT disaster?
This requires just a massive overhaul of configuration management. Experts are advocating for implementing rigorous, multi-phased configuration rollouts, often using techniques from something called chaos engineering.
Chaos engineering.
It involves intentionally introducing faults and stress testing changes in isolated, small environments before they are ever propagated globally. It's about designing operational systems that are aggressively defensive against human error.
I see. So you try to break it yourself in a safe space before it can break in the wild.
Exactly. Automated pre-checks must be robust enough to flag potentially catastrophic routing changes, ensuring that seemingly small network adjustments can't be instantly broadcast across the world without multi-layered human and machine verification. It requires really a level of paranoia to match the scale of the system you're managing.
Beyond all the technical fixes, there's a unique psychological layer to these failures. What happens to the user, to us, when these invisible systems we rely on for our income, for communication, for commerce, when they just unexpectedly seize up?
The psychological impact is one of profound helplessness. It's a disruption of our perceived control. Unlike, say, a power outage, which is visible and local, a massive digital failure is invisible, it's universal, and it's completely incomprehensible to the average user.
And the fix is entirely out of your hands.
Completely remote, managed by unseen engineers in distant data centers.
It creates this sort of cognitive dissonance, doesn't it? We know the internet is this vast, resilient thing, yet we experience it grinding to a halt because of an error we can't see and we certainly can't fix.
Exactly. And that sense of sudden systemic vulnerability creates real stress. It forces this momentary but potent recognition of how much trust, how much of our identity, our daily process, our economic standing, we delegate to a very small number of centralized hidden systems.
It's a sudden, unpleasant reminder.
It's a reminder that our highly optimized life is fundamentally dependent on the BGP routing decisions made by a few organizations.
Yeah.
And every time this happens, that collective sense of digital stability is eroded, and the underlying anxiety we have about our invisible infrastructure just grows stronger.
The Cloudflare outage was so much more than a simple technical glitch. It was a powerful global case study on the paradox of the modern internet. Our digital world is engineered for lightning speed and highly robust security through centralization, yet that same efficiency is the root cause of its most profound fragility.
And the tension we face is only going to intensify. How do we maintain the tremendous performance and economic gains of centralization while simultaneously investing in the complex, costly architecture that guarantees redundancy and strategic decentralization in the most critical areas?
And that leaves us with a provocative thought for you to consider. If the fastest, most efficient internet is also the riskiest, how much speed are you willing to sacrifice for genuine, non-centralized resilience? The answer to that question will fundamentally reshape the digital infrastructure of the next decade. Next episode, we're jumping into why Wicked, for good is suddenly everywhere online, and what it says about fandoms, film marketing, and nostalgia. Stay tuned.